Hi everyone, we've got a physics paper 2 exam question here on the magnetism topic. Now this is from the higher tier paper, but the questions, to be honest, I don't feel go beyond a level 5 really, maybe a 6. So if you're doing foundation, then I think this would be suitable for you as well. Figure 4 shows the magnetic field pattern around a permanent magnet. Where is the magnetic field of the magnet the strongest? So that is always going to be at the poles. How does figure 4 show that the strength of the magnetic field is not the same at all places? Well, the lines are closer together here around the poles, but then they're further apart away from the poles. So it's to do with the distance between the field lines. And that's how we know it's strongest at the poles. How does it show it? It shows it because the distance between the field lines varies. Figure 5 shows an electromagnet being used to separate iron and steel from non-magnetic materials. So we have a conveyor belt moving along underneath a big electromagnet, and on this conveyor belt we've got pieces of metal. Some are magnetic, the iron and the steel are magnetic, and some are non-magnetic, so there might be some copper or some other stuff in there as well. We have to explain one reason why an electromagnet is used instead of a permanent magnet. So if it was a permanent magnet, then we wouldn't be able to move away the electromagnet. Once the magnetic materials have stuck to it, they're going to stick there permanently. We need to be able to move them away and put them away somewhere else, away from the other pieces of metal. Otherwise, we need to be able to turn this magnet on and off. Okay, so electromagnets then can be demagnetized. So electromagnets can be demagnetized by turning off the current that's supplying turning off the source of the current to the magnet. Electromagnets can be demagnetized. That will make it easier to remove any metals that have been separated. Electromagnets can be demagnetized, allowing any metals to be separated and removed, let's say. Pieces of iron and steel are attracted to the electromagnet. Name 2 other metals that would be attracted. The other 2 types of magnetic metal are cobalt and nickel. So you need to remember those 4. 1, 2, 3, 4. And finally, the design of the electromagnet cannot be changed. Give 2 ways the force exerted by the electromagnet on a piece of iron or steel could be increased. So we can't change the size of the magnet. It says we can't change the design, but what we could do is increase the current. So if we increase the current in the flow that's creating, if we increase the current in the coil of the electromagnet, that would increase the strength or the force exerted by it. So increase the current in the coil. And second of all, what we could do is actually bring that magnet slightly closer, and the magnetic field would be stronger closer to the pieces of metal. So bring the electromagnet closer to the metal. Just a quick little bit of revision there on magnets, some of the stuff that you need to know. I hope that helps.